Today we'll go over some real basics of working with causal DAGs, the most simple notation for drawing them, as well as why they're useful. Be sure to grab a pencil and paper because DAGs are most helpful when you just start drawing them. So what's a DAG? DAG stands for Directed Acyclic Graph. I know that's a fancy schmancy name, but the idea is pretty simple, honestly. We'll identify some relevant traits of measures made and connect them with basic arrows. The arrows representing the causal relationships from one trait to another. It truly is that simple. Here's the most basic DAG around. So if we have the letter A, which we use to represent an exposure of interest, and we want to see how that relates to Y, which is an outcome of interest. So maybe it might be like patients who received a particular treatment will be healthier. So the exposure is treatment and the outcome is health status or something like that. Next, we'll introduce relevant context. We often denote this with the letter L. So this will be a confounder. Let's say that this is an observational study, so patients aren't being randomly assigned which treatments they receive. So there's probably a reason why they received one treatment or another, and it probably has to do with their health presentation. Point being, we don't know if it's that the treatment is causing improvements in condition or if, like, only healthy people get one treatment. Really, the difference in health status between treatments had nothing to do with the treatment benefit, but just the underlying health status of the patients who received the different treatments. We can overcome this problem. Maybe we'd stratify the analysis based on different patient subgroups or something like that. But that's the whole point, is trying to find ways to overcome the bias to detect which treatment is better for whom. In a nutshell, that's all causal DAGs do, is help you organize your thoughts like this. So what are the confounders? The common causes of both an exposure investigated, as well as the outcome that you're worried about. The real value of DAGs is when we start studying more complex situations. For example, let's say you have data at multiple points in time. So maybe you have a treatment patients received first. We'll put that as A1 with an arrow then to Y1 because the treatment should help people improve health status. But some people don't respond to treatment. So we'll introduce another letter, A2, and this is going to be the second treatment they got. And so A2 is going to be caused by A1, their original treatment they received, because you wouldn't be changing treatment if the first treatment had worked for you. But it's also caused by Y1, because depending on how bad shape you are in after that first treatment, that might influence the new treatment you get. And of course, then we can look at the information we're looking for, how A2, the second treatment you got, impacts Y2, how you did after the second treatment. That's the idea here. The basic idea of confounding isn't too bad, but when you start thinking in terms of how and when data are collected, there might be more interlinked pathways that are quite relevant to how patients are doing. And a causal DAG can help you think about all the different ways that things are interconnected. Here's another example of how DAGs can be helpful. So we've got the original setup where we have an exposure A causing an outcome Y, but let's say there's some unmeasurable trait, U. And let's say that this is also in the system. Maybe it's like a provider perception of patient well-being or something like that. And we can't really measure a provider perception because that's just an opinion. However, we can measure information on the influences of provider opinions. So maybe that's lab values or symptoms, all the things that go into forming an opinion, and we can base our analysis on that information, the data we can actually collect. And we'll denote that with the letter L because it's measured information as opposed to something unmeasurable that we just presume exists. These are just a couple examples. Writing DAGs is helpful because it helps clarify all the details of what exactly is playing out in your research context. This is just an organizational tool, really. It isn't about including every single causal path in the DAG. It's more about collecting your thoughts. What information do you have, and when was it measured, and how might the different traits and the timing of the different traits interact with one another? If you can draw a picture of how it all comes together, then you can have a better chance at really performing an analysis that will investigate your research question.